Welcome. This is Vericut software. Vericut is software designed for CNC machine simulation, verification, and optimization. Today we're running Vericut using a Makino DA300 machine configuration. The DA300 is a compact 5-axis machine. The DA300 has pallet capabilities, which can be simulated in Vericut, and tight clearances. This is the Vericut machine configuration. The machine configuration matches the real machine in all critical ways, including the CAD model being dimensionally accurate, the kinematics of the machine matching the real machine's capabilities of motion, and the machine controller being configured to exactly match the real machine's parameters, travel limits, and other critical features and functions. In order to run Vericut, you need basically what you need to run a real machine. You need the machine and control itself. You need a stock definition, a work offset, tooling definitions, and the NC program. All of this can be brought in from your CAM system using one of our CAM interfaces for all of the major CAM platforms. Once you've got Vericut configured, you can start the simulation. Before we do that, I'm just going to add an additional view of the workpiece so we can see close up the material removal that's happening. I'm going to perform a reset and then hit play here. The NC program executes line by line just like your real machine does. You can slow down the animation or speed it up so that you can catch any particular part of the program that you want to see. Even as you speed it up, the animation skips certain frames, but it will still find every error and collision that happens during that. As you click on the error down here in the Vericut logger, it shows you the line of the program where that error occurred. It also highlights in red the parts that collided with each other. To begin again, press play, and we caught another couple errors here as well. You can see as Vericut simulates, it's doing real material removal. I can adjust the view in real time as the simulation is running. I'm going to speed this up to get to the end here. The Vericut logger keeps track of all of the errors that occur in the program. So even if you're not watching it, you can come back later and investigate those, or you can configure Vericut to generate a report at the end of each run. Vericut also supports setup sheets, which can be automatically generated so that the machine operator can set up the tools and configure the machine exactly like the Vericut simulation. As Vericut runs and the tools change, the different surface colors indicate a different tool being used to make that feature. Vericut catches multiple types of errors, not just collisions, including this one, which says that Tool 49 does not support coolant through. As Vericut runs, the digital material removal leaves a cut stock that you can investigate using the X caliper function. You can measure dimensions, circumferences, diameters, wall thicknesses, all using the X caliper function. But a very fast way to see if your part matches your engineering design is using the Vericut Auto Diff feature. You'll find Auto Diff under the Analysis tab. And once the program is finished, you can compare the cut stock to the engineering design. Now that the program's done, I'm going to select the Auto Diff function. This is going to show both gouges and excesses. This part is not complete, as you'll see if we look at the stock design view. This is the final part. But through setup 1, we can check and compare the cut stock to the engineering design. As noted on the side here, blue indicates an excess and red indicates a gouge. You'll also note in the logger, Vericut is keeping track of the gouge size and volume. This accuracy in the simulation is what allows you to run parts with 100% confidence lights out on your first try. The goal of Vericut is to eliminate on-machine prove-outs, to give programmers a tool to check their programs before it leaves their desk, and to make work more efficient. If you'd like to know more about Vericut, you can find us on the web at vericut.com.